All right, so for 1b, you should have had, you should start off with sine squared theta plus cosine squared theta equals 1. So we already know what sine squared theta is. It's 8/17. So you should have that right here. Squared plus cosine squared theta equals 1. Okay, so what is 8 squared? Okay, 64. And what's 17 squared? 289. Okay, so what we're going to do is we're going to subtract 64 289ths from both sides. When we do that, we have cosine squared theta equals 1 minus 64 289. Yeah, well, you don't do a reciprocal here. What you're going to do is find a common denominator. So if I move this up so I have room, it would be 289 minus 64 over 289. What do you get when you subtract those? So you get 225 over 289. And now you're going to take the square root of that. So you should have had, it should be either 15/17 or negative 15/17. Because when you square root something, it can be positive or negative. Okay? Okay, so in your notes, you should be writing this down. Rotations of magnitude theta, it's a 0 with a line through it, and negative theta go in opposite directions. The two rotations are reflection images of each other over the x-axis. Thus, they have the same first coordinates, which is the x coordinates, but their cosines are the same. But opposite second coordinates, which are the y coordinates and the sine. Okay? So if you look at this one right here, this first one is going from here to here is a positive theta. So your x up here would be some kind of a negative x, because it's in the negative quadrant, right? And a positive y. But if I were to go the opposite direction in the negative theta direction, right here to here, notice that theta is negative. My x is still negative. It doesn't change because it's still on this side, but my y now is negative y. So that's what this is telling you, that if you go on if you have a positive theta, your x's don't change, but your y's are opposite. If you have a negative theta, yeah, basically that's what I just said. So, so in other words, your sines will be opposite, but your cosines will be the same. Okay, because sines are always your y values. Right? So, because of that, this opposites theorem, cosine negative theta is still the same as cosine theta. They're the same. Because your x values are not changing. Oops, that should be ing. This one right here, sine negative theta, is the same as negative sine theta. Well, that's because if you look at it, if this is the first one and then the second one, it's being reflected over the x-axis. So your y's are the opposite. All right? And along with that, your tans are going to change, because if one of them, of the sine or the cosine, change, then the tangent will also change. It just takes one of them to change. So in both of these, because the y's are opposite, that'll make a negative tan. Okay? Sines and cosines of theta plus 180 or theta plus pi. So this is just telling you, basically you're adding a semicircle to where you're at. Okay? You're doing a 180. If you're in a car going west and do a 180, which way are you going to be going? East, right? So this is kind of the same thought plan. So on this first one, adding 180 to pi to the argument of theta of the trigonometric function is equivalent to rotating halfway around the unit circle. Okay? So, for all theta, cosine 180 plus pi equals negative cosine theta. So let's look at the unit circle and see what we're talking about here. If I am at this point right here, my x and y it's x and then my y is actually 0, correct? But if I were to go the other direction, what would be my x over here? It's going to be a negative x, right? So, and my y would still be 0. My y doesn't change on this part. However, if I were to do it from here, say I have this, my x would be positive and my y would be positive. And then if I move this direction, what happens? My x is what? Negative. And my y is negative. So in other words, because the 0 were for the y's here, the y didn't change just because they were 0. But in general, they will. So look, this says when I add a half circle to cosine, it becomes a negative x. If I add a half circle to sine, it becomes a negative y. And if I add a half circle to tan, it doesn't change it at all. Because remember, tan in this quadrant is positive, tan in this quadrant is still positive. Okay? Okay, sines of cosines of supplements. Recall that the angle has a measure of theta. Then its supplement has a measure of 180 degrees minus theta. Or pi minus theta. Okay, think back to geometry. Okay? When you were in geometry, you had something called supplementary angle. Correct?
Pi minus theta.
Yeah, that's pi minus theta. So, if I had a supplementary angle, the two angles added together would be what? 180. Okay? So, thus the reason why they're using 180 minus pi. Because if I were in a circle, okay, this one, say this is theta, this is going to be what? Yeah, 180 minus theta.
So it's the same as the angle.
Yep. Okay? And then if you're using pi, it would be pi minus theta. Okay? So, that's saying that if you're adding, if the supplement of sine 180 minus theta is still going to be positive. So, if you look up here, your y is positive over here, your y is positive still over here. But your x is positive here, what's your x over here? Negative. That's why it's negative. And if your tan's positive here, your tan's going to be negative here. Thus it's negative. It says, given that sine 10 degrees is this, find the value of x other than 10 degrees and between 0 and 360 for the same amount. Okay? So, in other words, if I actually think back about which one of these I can use to find the same value. 180 minus theta is the same as theta on this. So I'm going to use the Supplements Theorem on this. So I can say 180 minus 10 degrees, which is 170, that will give me the same value as sine 10. So sine 170 is equal to sine 10. Okay, so think about your unit circle here. If I have sine 10 right here, my y is, it says 0.173 is my y value. Okay? Take out that. Oh, So my y value is 0.173. Now, if I move over to this side, what is my y value there? Yeah, it's the same. Okay, so that's what this is trying to say. Okay? Okay, so example 2b, given that sine 172 is this, find the other x that has the same value. So what is it going to be? Yeah, you're going to take 180 minus 172, which happens to be 8 degrees. So sine of 8 degrees is sine of 172. Yep.
So is that all we have to do for that problem?
Yeah. Yep. So when it's telling you to find an equivalent sine, you're going to use the Supplements Theorem. Okay? So if an angle has a measure theta, then its complement has a measure of 90 degrees minus theta, or pi over 2 minus theta. So back to geometry again. Remember, a complement is when you take a 90-degree angle and add one angle to the other to make 90 degrees. Okay? So if I go theta here, my complement here is going to be 90 minus theta if I'm in degrees. Remember, in the unit circle, this part after the first quadrant is pi over 2. So that's why they get pi over 2 minus theta. So the complement theorem is saying that basically my complement of sine is always my cosine. And my complement of cosine is always my sine. Okay? So before, when we were talking about supplement, trying to keep the same, that's true. But look, my complement of sine from here to here is the opposite. So, let's see if I can. For instance, you have a triangle, theta. You know that sine theta is opposite over hypotenuse. Okay? Now, you also know that this is a 90-degree angle. This angle over here is what to this angle? It's my complement. It has to add up to be 90 degrees because this is already 90 degrees. And remember, how many degrees is in a triangle? 180. So this is my complement, right? So if I do cosine of this particular one, let's call that particular angle, yeah, we'll call it R. That sounds good. Okay, let's call that R. My cosine of R happens to be this same one because it's usually your adjacent, right? I'm just going to call it op because we already named it op over hypotenuse. Notice how they're equal to each other. Okay, so that same thought plan is going into this. It's saying your complement of your sine angle happens to be your cosine angle. Okay? So, let's look at this next example. Given that we have sine 30 equals 1/2, compute the exact value of each function below. What we're going to do is use all these theorems that we were talking about above to find these. Okay? So the first one, we want to look at cosine 60. Which of the theorems that we were looking at above matches something to do with this? The Complements Theorem. So, because we're using the Complements Theorem, I'm going to write that down. Okay? What is cosine 60 going to be? It's going to be 1/2. Happens to be the same as sine here. This one, cosine 30. How do we find that one based on the theorems that we found above? You might need to look back at first page.
The opposite?
Nope. Nope. Pythagorean. We need to use the Pythagorean theorem to find that one. Okay? So I'm going to write Pythag here. So what we're going to do is I'm going to take cosine squared 30 plus sine squared 30 equals 1. Well, my sine squared 30, my sine 30 is 1/2, so this will be 1/2 squared. Cosine squared 30 plus 1/4 when I square it. Okay, now what do I do to both sides?
Minus 1/4.
Yep, minus 1/4. So this will be cosine squared 30 is going to be 3/4. Do you know how I got that? Okay. So it'd be 1 becomes 4/4, right? 4/4 minus 1/4 is 3/4. And now what do I need to do to find this? Just take the square root. Yep. So that's the square root of 3 over 2.
So the cosine of 30.
Yep. Square root of 3 over 2. Okay? All right. Sine 150. Yeah, it's a half turn from 30, right? So I'm going to take the half turn one. Oh, actually, this is supplements. This one should have been supplements. The next one's half turn. Because we're adding 180 to 30 in that one. So this is a supplements. Okay? And if I take 180 minus 150, that equals what? 30. Okay?
So sine
So,
equals sine 150.
yeah, sine 30 equals sine 150. So what's my answer going to be on this one? 1/2.
What?
Yep, because it already told us right here, sine 30 is 1/2.
No, but that doesn't make sense. Okay, you take 180 minus 50, minus 150, and you get 30.
Mm-hmm.
And because it told us that sine 30 is 1/2, then it's 1/2.
Well, remember, go back to the supplements theorem. What does it say?
It says, for all sine 180 minus theta equals sine theta
Mm-hmm.
equals sine pi minus theta.
Right. So in this case, we took 180 minus theta, which is 150. So that way they're both equal. We already knew sine 30. Okay?
Yeah.
So 180 minus 30 is 150. Okay? So that we know that those two angles happen to be equal to each other because it's the supplements theorem.
So how did we get 1/2 though? Like I don't get why.
Because they gave it to you in the very beginning. Right here.
So what if it doesn't give it to you?
Well, then you're going to have to either use a unit circle or, yeah, use a unit circle to find it.
That doesn't make sense.
On these ones, they're going to give it to you, though.
So I should just, every time I supplement, I should just put whatever the number is?
Yeah, it's going to give it to you. Okay, we have more to show you. That's like that. Okay, cosine 210.
Okay, I don't understand what.
Cosine 210. Well, that is your half turn because that's actually 180 plus 30, right? So that's the same as the half-turn theory, or the theorem. So, so we know that cosine 210 is going to be equal to negative cosine 30, based on the half-turn theorem. If we go back and look at that, here's the half-turn theorem. Notice that if I add 180 to my theta, it's going to make me a negative cosine. Okay? So that's what I'm using.
Wait, who made all this stuff up?
All right? So we already know cosine 30. What was it? Nope. It's right here. We found it earlier.
But that's not negative.
No, I bet it will be once we put it in. So this one's going to be negative square root of 3 over 2. Huh? Right? And then this one, sine negative 30, is the same as our theorem of opposites.
Wait, that was the answer?
Yep.
Because we just made it negative?
Yep. Based on that theorem, it just told us to make it negative. Okay, so we're using the theorem of opposites. So if I put in a negative 30 degrees for sine, what happens to it? Yeah, it becomes a negative sine 30. Yep, so this is going to be negative 1/2. So the trick to doing all of these, you guys, is you're going to need to be going back and forth with all your theorems and trying to make them work with it.
You have to do 32 problems.
Okay, so on this one, they gave us sine x equals 0.681. It wants to find out what cosine x is. So what am I going to use to find that now?
Wait, hold on. What do you use for complement?
Well, Pythagorean, because it happens to be the same x value. They both have x. So let's do the Pythagorean. We're going to have cosine squared x plus, I'm just going to go ahead and write this in as 0.681 squared equals 1. Yeah, because this is under, okay?
Yeah, sorry.
So if you square it and then subtract it, you're going to end up with cosine squared x equals 0.536. I did 2 steps there.
And then you have to square root it.
Then you square root, yep. So if we take the square root of both sides, we have cosine x equals, and I found 0.732. Okay.
And is the next one Pythagorean too?
Nope, next one's tan. How do you find tan again? Sine over cosine. So sine over cosine.
So would it be 0.681 over 0.732?
Yep.
What does that equal?
That should equal, I got 0.930.
And then this one would be opposite?
Opposites, yeah, good. So we know that the opposites of this is going to be what?
Negative sine.
Yep, negative sine, which is negative 0.681. Huh?
Wouldn't you still have to find the sine for it?
Nope. Well, it already gave it to us right here. Okay, what's D going to be?
I don't know.
Supplement. Yay! You guys are awesome. Okay, so if that's the case, what's the sign of the supplement?
Is it pi minus 0.681?
Yep, but is it going to be the same or different? Go back to your supplements theorem. It's going to be exactly the same, right? So, what is that going to be then?
Will it be 0.681?
Yep, 0.681.
Wait, why? Why?
Because our theorem tells us that if you take the supplement of this one and put it in, you're going to end up with the same value out.
So if we do, wait, hold on. If we do 180 minus 0.681, it'll equal whatever it equals, and then that equals 0.81? Or 0.681?
Well, but 180 minus x, you're not actually putting this in to,
Well, yeah.
okay? So whatever x was, you're going to end up with the same value for the sine. Okay? Now, last but not least, cosine pi plus x. What is that? What do
Half-turn.
half-turn. Good.
I don't know that was the last one.
Okay? So we already know what cosine x is.
What is it? 0.73?
Yep. So a half-turn of cosine is the same as negative cosine x, right?
So negative 0.732.
Yep, negative 7.32. All right, 0.732.